uses very good, raw, authentic thought processes, and you'll be going through the same struggle, if not probably more of a struggle, just because you've never seen it, right? So I'm looking for my limit as I approach 2 from the left. So the first thought is, why is it from the left? Do you think? John? And so what? Keep going, elaborate. Okay, it's undefined at 2. That part, though, has nothing to do with the cubed root. Why is this undefined at 2? Because you would get... Right, you'd get a denominator of 0. Does it exist to the right of 2, though? If I plugged in 3, right? Think of your number line. I know this calculus makes us forget what the heck is to the right of 2. 3 is to the right of 2. It does, doesn't it? Have a way of doing that? I can't explain it. Okay? Does this exist when x is 3? Sure. It's just, it definitely doesn't exist at 2. Is that because of a hole, or is that because of an asymptote? Vertical asymptote. Vertical asymptotes come from the zeros of your denominator. So if we were to directly evaluate and plug in 2, we would get 1 over 0, which does not exist. And it would be because of an asymptote. So now that we know that there's an asymptote there, just by thinking that through, we know that this answer is going to be one of 2 things. What are the possibilities? Infinity or negative infinity. We're approaching an asymptote from a certain side. But we definitely can get more specific, because it's not asking about approaching 2 overall. It's just one side, so there has to be a more specific answer. So we're just going to figure it out. We're just going to plug in something slightly to the left and decide, is it giving me a negative number or is it giving me a positive number? Now, if I take 1.9 and square it, is that number going to be bigger than 4 or less than 4? Slightly less than, or maybe, yeah, slightly less than 4. So that when I subtract 4 from it, I'm going to be in the negatives, right? And when you cube root something, and it will be pretty small, right? The closer 1.9 gets to 2, the closer the squared version will get to 4, but it will always be underneath. And so when I subtract 4 from it, I'll be a tiny negative number, essentially. And then I take the cubed root of a tiny negative number. And that cubed root of the tiny negative number makes it become even tinier, right? The fact of the matter, it's 1 over a negative tiny number. And when you take 1 and you divide it by a tiny number at all, it's going to be some sort of infinity. And because there's a negative sign there, the answer is negative infinity. Okay? Now, a lot of these you have no idea what the graph looks like, and nor should you. But sometimes it's just helpful and reassuring to look at it. So 1 over the cubed root of x squared minus 4. And we'll see what happens as we approach 2 from the left. There's 2 from the left going towards negative infinity, right? Any questions? Okay. All right, flip to the back. This one's actually not so bad. The thinking ones that actually 1, 2, and 3 I think are been harder so far. So maybe if we have time, I'll re-explain those live for you. But we're approaching negative 1 from the right. And again, why is it asking me from the right? Usually there's a reason. Every once in a while, they'll throw that in there, and it really is kind of funny because the overall limit would have existed anyway. But why do you think from the right? What's happening at negative 1? There's a hole. What's making you say that? Right. That question I just asked is probably a little premature because we can factor and cancel and simplify this first, right? Sum of perfect cubes turns into x plus 1, x squared plus 2x plus 1. That's not right. X squared minus 1x plus 1. The x plus 1 cancels, which tells me there's a hole at negative 1. And this whole thing just reduced to 1 over x squared minus 1x plus 1. So maybe, forget from the right, maybe I should just start to, well, I should probably just check it anyway. Redirectly evaluate. Sienna, do you have a question? Okay. So if I redirectly evaluate and plug in negative 1, I get 1 plus 1 plus 1, which is 3. So this is a funny one. Why are they asking me from the right? I don't know. Because it seems to me that there's just a hole at negative 1. And if it's just a hole, from the left or from the right does not matter. So let's take a peek at this. X plus 1 divided by x to the third plus 1. And zoom 6. What were we looking for? Limit as we approach negative 1. Yeah. The limit exists. There's no asymptote. It's just a hole. So this would be one point in time where I found an example, and it's rare, where they ask you about that limit coming from one side, but the reason behind that, I don't know if that's just to throw you off, or, I don't know, keep you honest, so that you're not just always putting an infinity or a negative infinity. I don't know what their logic is, but I pulled that from the book or from a question online, or maybe it was just a typo. Maybe they didn't even mean to put from the right, but they did, and we answered it because that's what they were asking, 1/3. But it would have been the same from the left or the right. Capiche? Capache. All right. Last one here. Oh, take 3-4 minutes on your own and try to play around with this on your own. Raise your hand if you have answers. Just your best guess is mine. What are your thoughts of what I think? Where are you so far? I'm curious. This is the dooziest of the whole sheet. And further, I don't think I should have put it on here. I never used to, I'll say this, I never used to spend a day just getting, like, putting literally these are the 6 most difficult ones. Well, maybe not the previous one. Exercise 5 wasn't hard at all. But I grab like these really weird ones that just don't have, a great way. Manipulation doesn't work, or thinking about the look of the graph certainly doesn't work, right? Did anybody try to manipulate this? I didn't try that yet. No? I don't know what you could do even. If this was theta approaching 0, we could capitalize on those trig limits that we learned on Friday, right? But if it's not approaching 0, we can't do those, unfortunately. So here was my thought process. I first tried to directly evaluate. As you always should, it's indeterminate, okay? So I got to do something else. Manipulating, I didn't know what the heck to do. There's nothing really to do if you manipulate. No complex fractions, no rationalizing, none of that. So from that I thought, well, let me just go to the least efficient method, the most mind-blowing method, but you got to put your brain through that struggle sometimes. What if I approach pi from the left versus the right? So I first looked at what would happen if I approached pi from the left. So if you're talking about, not really a number line, but if you're talking about the unit circle and you plug something in slightly less than pi, right? Sine's progression as you go around the unit circle, the sine of 0 is 0, then it increases to 1, and then it decreases back down to 0. So if you're plugging in something slightly to the left of pi, the sign of it is going to be a teeny tiny positive number. Yes? Because it is in its progression from 0 up to 1 and then back down to 0. But it's right before it gets back down to 0. So the numerator is a tiny positive number. The denominator, if you plug in, if pi is 3.14 and you plug in 3.13, you're getting another tiny positive number. The problem is I don't know how tiny one is getting relative to how quickly the other one's getting tiny. And so it leads us to that weird spot. But if you were guessing, what's a tiny positive number divided by a tiny positive number? 1, maybe? What'd you say? No. 1. And then same thing happens from the left, or from the right rather. If you plug in something slightly bigger than pi, Now we're into a tiny negative number, because isn't sine, all students take calculus, isn't sine negative in this quadrant? But you'll be just negative. So here sine is 0, but you're a teeny tiny negative number. And then in the denominator, 3.14 minus 3.15 would be another teeny tiny negative number. And again, anything divided by itself would seem to be 1. So if I were guessing, my best guess would be 1. The problem is tiny over tiny is still indeterminate technically. So I won't give you something like this because it's still indeterminate. Really the only way is going to be to look at a table of values and look at a graph. If we do that, here's the graph of it. I made the graph go from 0 to 2 pi. Here's pi. So what's the limit as we approach pi? It is 1. It did end up being 1, but that I want you to know that is coincidental. Tiny over tiny is not something we're going to say, oh, that's always 1. Yeah. Sine squared 1 minus cosine squared. Why what are you doing? You're playing around with it? That would be the one thing I would try to manipulate, but conjugate of pi minus theta. So you multiply by. I gotta look at it. I can't follow that without seeing it. Yeah. Don't worry about those limits so much. And like I said, I won't give you one like that you can't do. I'd have to show you the chart or I'd have to show you the picture. But down the road, there will be a specific set of rules that you will use for that, like special case. But right now, we're trying to wrap our heads around the concept. Dominic, yours is coming in this bunch. Oh my gosh, look at this. You're doing all of the packets. There's only 13 questions. This is on the back of all of your packets. I must have just been playing around with this question. And I clearly didn't get very far.
I tried to do that.
Did you? So I was just clearly playing around, trying to do something to manipulate. No such luck.
I was just going to put Jim
I know. That's okay.
I'm on a flow.